Okay, so getting into I guess information first about proofs, and then we just have some examples on the back of going through some proofs, and you'll have some time to work. And think of the algebraic proofs that we went through too, where the whole idea with proofs is that you're working through and you have certain statements, like we had done algebraic proofs, like this is the next step to solving the equation, this is the next step, and you're stating the reason why you know that's true. But to start out at the top, because in your properties packets, we've talked about postulates, and I think I mentioned theorems, but the difference between them, theorems are statements that can be proven. So if something is a theorem, it's something that has been proven. There's a proof for just that theorem. If something is a postulate, like the segment addition postulate, that is a statement that's accepted as true. So it's not proven, it's just accepted as something that's a fact. And we had looked at a lot of postulates dealing with points, lines, and planes just based off of the definitions of those three. This is the two-column proof process we'll be working through. So as we work through these, step one, if a picture is not given to you, and the proofs we're working through today are with segments, so that's helpful too, is knowing, am I drawing a segment? What am I drawing? So you should always know what your proof is about. We'll be doing proofs with segments today. The next lesson is proofs with angles. In later chapters, we prove things with triangles, so knowing even what you're drawing. But drawing a picture, labeling that, you'll always be given some information, so understanding what is given to you, and you'll always be told what it is you're trying to prove. So understanding what you're given and therefore what it is you're trying to, what conclusion you're trying to come to. Marking your picture, like I said, going along with drawing your picture, so labeling your picture. So if you want to put mark or label. So what that would mean is if you know that something is congruent to something else, labeling that on your picture so you can visually see that. Or if you're given the length of something, labeling like the length of this is 10. Step 5 is looking for freebies. So you won't see this today because we're not dealing with angles, but freebies would be like if you see you have vertical angles somewhere because we have a vertical angle theorem. Or things that are shared, like a shared side or a shared angle. But again, angles will not appear in your proofs today, so we'll talk about freebies as we go through examples. And then it can be helpful to work out the proof in your head. So maybe look at what you're trying to prove and try to work backwards to see, like, can you make sense of why that would be true? And then you're writing the proof, justifying each statement with a reason. The properties packet, these are your possible reasons. So that list of properties. So definitions, algebraic properties, postulates, theorems, anything from your packet. And so we're going through two-column proofs today. This is what they're going to look like. So it contains your statements and your reasons organized in 2 columns. You'll see some of these things today are going to be filled in. I've given you them. So I might have given you some statements, given you some reasons. But ultimately, I want to work to the point where I don't have to give you anything and you can fill that in. But it's all problem solving. So these are tough. You just got to stick with it. Paragraph proof. So 2-column proofs are really a model for paragraph proof. So a typical proof in math is not set up this way. But this helps you understand how to set up a paragraph proof, which is writing sentences to explain why a conclusion is true. So in each sentence, it would be like each row here would be a sentence. So each sentence would cite the reason justifying why it's true. And again, your reasons are going to be definitions, properties, algebraic properties, postulates, or theorems. So what was stated above. And we will be doing paragraph proofs eventually. We're starting out with 2-column proofs, but again, a paragraph proof then would just be taking your 2-column proof and each kind of line here, you'd say this is true because of this reason. So you'd just be converting your 2 columns into sentences and then into a paragraph. And then as was above in step 6, where it said reason backward. So working backwards is one method for writing a proof. So look at what you're trying to prove, work backwards in your head until you reach what's given to see if you can make sense of why that's true. You could also just try to work forward in your mind too. Start with what you're given and try to work it out in your mind before you start writing it down. Because the tough part then is looking at the reasons. So let's look at some examples. So in example 1, we already have a picture and it says that we are given. So here's where notation matters. Notation makes a big difference. So if I have BC is equal to DE, can somebody tell me first of all what that means in relation to my picture? Like what does BC mean? The line segment, what about the line segment? Because if I had, this would represent segment BC. So if the segment line or segment symbol is above it, that means segment. What does it mean if there's no line above it, Emma? The measure. So this is saying the measure of BC is equal to the measure of DE. So these are both measures, or I'll put / lengths. The measure is a length. So the measures or lengths of segments. But measures we always describe as being equal. The segments themselves would be described as being congruent, which we don't have. But again, notation, it's important that you know what the notation means, because in some proofs, you will see kind of going between the congruents, or 2 segments are congruent, going to their measures are equal, and there's a property that says that. So I'm given BC is equal to DE. So I'm going to mark that on my picture. If I know that the measures are equal, I know they're the same, they're congruent. And that marking is just kind of putting a line here. So I don't have to draw the picture, but I can mark it. I understand what I'm given. And then don't mark anything about what you're trying to prove, because this is not given information. This is like the end of my proof. I'm trying to say that AB plus DE equals AC. So if you look at this picture, again, to understand what you're trying to prove, I'm trying to say that this segment here plus this segment here, so AB and DE, if I add those segments together, I should get the same length as AC. Okay, that's what you're trying to prove. Hopefully by looking at that, it makes sense because you know that these 2 things are equal. So knowing these 2 things are equal, I should be able to add AB and DE to get the length of this. But that's what I have to come up with the reasons for. So the only thing I filled in this proof, because again, we're going through it together, you can see I do have it labeled how many steps you should have. You always start with what's given. So BC equals DE. That was given information to me. So my reason is just given. If you're given multiple things, it's possible that all of the things are listed in step 1, or they could be listed in different places throughout a proof, but that's given. Now I have to decide where to go from there. What I am going to fill in, though, is where I'm trying to end up. So I'm trying to prove, this is going to be my very last statement. What I'm trying to prove is that AB plus DE is equal to AC. I don't have the reason yet. I think I mentioned this with algebraic proofs. You have to list the reasons in order, so you can't just skip to step 3 and say why you know that's true. You don't know why that's true because you don't know what step 2 is. So I have to figure out what else can I say here to get me to here. So if I look at my picture, I first can start out with, since I have this whole segment, I first can start out by saying, well, just by looking at my picture, I know that AB plus BC is equal to AC because I have this whole segment. So I know AB plus BC is equal to AC. And then here's where you look in your properties packet for the reason. Anybody know the reason why I know that's true? Okay. Yes, that's segment addition. I'm just adding two segments to make a whole segment. So segment addition postulate. Okay, and then notice, well, now I can just go straight to what I'm trying to prove, that AB plus DE equals AC. And when you're working through a proof, just like with algebraic, it's like you're moving one step to the next. So you always kind of look at, okay, what did I state before and how can I use that information to come up with what my conclusion is? Anybody know what this reason might be? Why I can go from here to here? Okay. It is substitution. So if I look at line 1, I know that BC and DE are equal to each other. Okay, if I look at line 2, here's where I have BC. All I'm doing from line 2 to line 3 is replacing BC with DE. Because I know they're equal, I can do that. So that's the substitution property. Or if you just put substitution. Okay, so you kind of look at the lines that you have above and use those to fill in the rest. Questions there? Okay. In the second example, here we're given a few different things. Again, all I filled in on the proof, because we're going through it together, is what you're given. I had filled it in different places. I didn't all fill it in line 1. So we know Q is between P and R. Now we already have a picture also. So I can see Q is between P and R. R is between Q and S. And then I know that PR, the measure or length of PR, is equal to the length of QS. So in order to mark that on my picture, I'm going to do this. So this is PR, this is QS, and I know those are the same. I am trying to prove, so I'm not going to mark this, I'm trying to prove that PQ, so this little segment, is the same as RS. So that these two little segments are the same, is what I'm trying to prove. So that is going to be my very last line. I just have to figure out how to get there. Okay, so let's start with what we are given. Again, I broke this up and you'll see why. So first thing I was given was that Q was between P and R. I'll do this. So all of this that's given, I just listed in different steps here. But that's all given information. So Q is between P and R, reason number 1, that's given. Now, if I know, I'm trying to get you to use what's given. So if I know that Q is between P and R, anybody know a statement I can make about this segment here? So anything I can say in regards to this picture. So I'm ignoring the point S here. But if I know Q is between P and R, anything you could say knowing the properties we have about that segment. maybe look at the proof we did above to help you. Just, yes, Quinn. Yes, so if I know that a point is between two other points, I can use that segment addition postulate and say, well, what I know so far, or what I can state based on the picture, is PQ plus QR should be equal to PR, the whole thing. So PQ plus QR equals PR, and that's segment addition postulate. Because if you are given information, you should be using it for something. So I used line 1. So you could also kind of make a mark like, okay, I've already used this information to make the line number 2. Then line 3, R is between Q and S. So if I know that, well, I should say line 3, that was given to me. Okay, that was given information. So if I just look at this segment, R is between Q and S, what conclusion can I make there? Kylie? Yes, same thing. QR plus RS is equal to QS. Segment addition postulate. Okay, so I used the given information in line 3 to make that conclusion. Then the last thing I was given, I know that PR and QS are equal. That was given to me. So now I have to go off of, notice I kind of crossed out lines 1 and 3 because I already used that information to make these conclusions. But now I have lines 2, 4, and 5 that I can use to make some sort of conclusion in line 6. So I have in line 2, PQ plus QR equals PR. And in line 4, QR plus RS equals QS. And in line 5, I have PR and QS are equal. So if I take a look at this statement, and then I look at these two equations, here's PR, here's QS. And line 5 tells me these two things are the same, meaning in line 6, I should be able to say if these two things are the same, then what they're equal to, these two things should be equal to each other. So it's like I'm taking, looking for a different color. I'm trying to outline what I'm saying here. I'm taking this and I'm putting it into here for PR. And then I'm taking this and putting it here for QS. So using those 3 lines, I can say that PQ plus QR should equal QR plus RS. And what I did is I made a substitution because I know, again, this is being substituted in place of PR. This is being substituted in place of QS. So I used substitution here. Okay, so now I've used those 3 lines. I've used 2, 4, and 5 to make this conclusion. We're almost there. Anything you notice about this equation? I heard somebody say it. There's two what? There's two like terms. There's two QRs, I heard somebody say, and they're on different sides of your equal sign. And then notice what's left. If I were to get rid of those, I'm left with what I'm trying to prove, that PQ equals RS. How would I get rid of these? Subtract. It's an equation. I just subtract it from both sides. So here's how I'm going to write that. Because it's not how you would normally write it if you were just solving the equation. You'd probably just write underneath it minus QR and cross them out. I'm going to write it this way, that PQ plus QR and then minus QR to show that I'm subtracting it from that side equals QR plus RS minus QR. So I'm subtracting QR from both sides. What property is that? Okay. Yep, that's that algebraic property, subtraction property of equality. When you subtract the same thing from both sides. So it doesn't have to be that you're subtracting a number from both sides. It could be you're subtracting the same, in this case, the same measure from both sides. And then by doing that, again, the QRs cancel out and you're just left with PQ equals RS. So the reason for this one, this would just be like when we did like the addition, subtraction, multiplication, or division facts. It's a fact that QRs, when you subtract from both sides, they're just going to be gone. So this would be a subtraction fact. That QR minus QR is 0, essentially, is a subtraction fact. Okay, but notice how you're kind of building, using what you're given to say what conclusion can I make, and then now I have this equation trying to get to what you're trying to prove. Questions there? Okay, the last three, this is just some one-step proofs dealing with congruency. So I just want to talk about these quickly. This is like you had on your quiz, or like we did that very first day of chapter 2. So it says, if you say you're given segment DE is congruent to segment GH, and then you're concluding segment GH is congruent to segment DE. So all that's happening is the two sides of your congruency equation are switching. Anybody remember what reason that is, or what property that's using when you switch the two sides of your equal sign, or in this case, congruency symbol? Symmetric. Yes, this is the symmetric property. I'm just going to abbreviate property, put prop. What about in 4? If you're given segment AB is congruent to segment RS and segment RS is congruent to segment WY, therefore segment AB is congruent to segment WY. Transitive. So notice AB and WY are both congruent to the same thing, therefore they're congruent to each other. That's transitive. And let's just look at the last one. AB, so this is now measures or lengths of segments. AB is equal to EF plus FG, and BC is equal to EF plus FG. Therefore, AB is equal to BC. What would you think for this one? Those two things are the same. Any ideas? Quinn? Substitution, I would accept substitution, or what else could you say it is? Not subtraction. So substitution, I would accept. Or, okay. Nope. Nope. Let's say I switch this around. EF plus FG equals BC. So look at that and look at what I have above. So if AB is equal to this, and this is also equal to BC, then AB and BC are the same. It's the exact same thing this is saying up here. You just have things added together. So this is like if A is equal to B and B is equal to C, then A is equal to C. So transitive would also be what you could say for that one. But if you had substitution, I would accept that too. Because it's like you're substituting BC in for this or AB in for that. Okay, so I'm going to pass out your assignment. I know this is the first time you're working through these. You do have work time. I want to help you get started on the first one. Because there's one property that we didn't have in our examples. That does come up quite a bit. Okay, so if you look at your assignment, and like I said, notice there's some statements and some reasons I have filled in for you to help you. But again, don't try to skip to the end and fill things in out of order. So in number 1, there's already a picture for you. If you look at number 2, I have a segment drawn, but nothing's labeled. So 2, you're going to have to label your picture before you start. On the back, 3, 4, 5, and then 6, 7, 8. These are like one-step proofs. You're just naming the properties. The proof for number 9, you'd have to draw your own picture, and then there is a picture given for 10. So that's in terms of pictures. But 1 already has a picture. We are given segment AB is congruent to segment DE. So I can mark that AB and DE are congruent. And then I know B is the midpoint of segment AC and E is the midpoint of segment DF. Okay, so if you look at how this proof is lined up, notice I gave 3 lines for statement A, and then I have the reason is given. So you can actually label all 3 of those things all in step A. So in step A, I can write AB, the segment is congruent to DE, and then I can say B is midpoint of segment AC, E is midpoint of segment DF. Okay, that's all given to me. And then remember, it's like you're using, you now look at what am I given and how am I using that to make conclusions. Ultimately, I'm trying to prove that BC and EF, that these segments are congruent to each other. That's what I want to prove. So line B, I already have the statement given to you. AB is equal to DE. So if I look at what I'm given to see why do I know that's true, up here I said that segment AB is congruent to segment DE. Therefore, I can make the conclusion that the length of AB is the same as the length of DE. There's a property that says if segments are congruent, their measures are equal. Anybody remember the name of that in your property packet, or look at your property packets to see? If the segments are congruent, the measures are equal. What tells me that? That is the definition. I'm going to abbreviate definition. Definition of congruent segments. That's just what it means to be congruent. Okay, but if you're wondering this, I used this given information to make that conclusion. That is why I know that's true. Now, I also want to help you with the next 2 lines here in statement C. Now look at the other information you're given. And I did give you the reason as being the midpoint theorem. But if I know, let me just go up to segment BC. If I know that B is the midpoint of AC, what does that tell me? If I know that B is the midpoint of AC, what does that tell me? Quinn? Okay, I do know that AB plus BC equals AC. B bisects AC. We're getting there. Yep, AB is the same as BC. If B is the midpoint, then I know that AB is the same thing as BC. A midpoint bisects a segment, cuts it in half. So that's the conclusion I can make. AB should equal BC. The reason why there's a second line is because I have also been given E is the midpoint of DF. So I can make that similar conclusion that DE should be the same as EF. Okay, and both of those conclusions are because of the midpoint theorem. So again, I'm kind of drawing arrows to show you I'm using the given information to make those conclusions. So now I'm going to let you go from here. I've given you the next 2 statements. And now you have to kind of figure out, use this information, or rather all of these, use this information to now make these conclusions. Okay, I'm going to let you go from there to try to fill in the rest, and then you do have other proofs. So do your best on this. Proofs are hard. The only way for them to become easier is for you to work through them. It's all problem solving, and problem solving is tough. Okay, but you need to work through it.